here with Justin Boggs and Thomas Fortier here in the San Francisco location of the Adobe offices. Justin and Thomas, why don't you introduce yourselves?
Sure. Again, Justin Boggs. I'm on the CPU ISV Developer Relations team.
And I'm Thomas. I'm Justin's equivalent, but on the graphics side of the company.
Cool. So why don't you guys tell us a little bit about what you're doing here today?
Well, we're doing some future technology planning with Adobe, and we work really closely with them to make sure that their software is as optimized as possible on our hardware. And I mainly focus on the CPU optimizations, making sure that it's well multi-threaded and it runs well on our latest processors. And Thomas works on the graphics side.
Yep, so I work with Adobe on the graphics side, working with them to try to offload some of the computations they do done historically on their CPUs onto the GPU to get better performance in their professional and consumer applications.
Great, so that's a pretty hot topic right now, is getting the most out of the graphics performance. Can you tell us a little bit about some recommendations that you might have for somebody getting into this area?
Well, I think for now, there's a lot of optimizations you can take advantage of the standard APIs today. So there's like DirectX and OpenCL are the standard APIs for taking advantage of your graphics card and offloading some of those computations to the graphics and the graphics processing unit, the GPU. There's new APIs that are just being worked on and just being finalized now, called one being OpenCL. So OpenCL is a API that you're going to be able to use to offload some computation to the graphics card. And that's a really exciting new API that developers definitely should check out. It's OpenCL.
But AMD is a hardware platform company, so we produce CPUs and GPUs. So whenever we work with developers, as a team, Justin and I, we really try to focus on finding a way to design algorithms such that they're well distributed across a set of CPUs and GPUs in a system. So we're trying to create a well-balanced hardware systems such that software solutions run efficiently both on the CPU and GPU, so that overall the experience for end users is optimal. So we're not just focused on the GPU or the CPU, we're trying to take the two together to create the best platform possible for the computer.
And I imagine that with more cores being added to the CPU, that's also a big focus, such as multi-core programming, multithreading. Is that something you guys work on as well?
Definitely. So let's just take video editing as an example. So video editing is very CPU intensive today, and it's very multi-threaded, so it's taking advantage of lots of cores. So you've got a 4-core, 8-core, say, Phenom 2 or Opteron machine, it scales very well. Another thing that we're also looking at for the future is how do you load balance again between the CPU and the GPU, because some of that you can offload to the GPU. There's certain kind of like performance characteristics and fidelity requirements to making sure that there's pixel accuracy and things like that between, if you offload part of your encoding of your video editing process to the CPU and the GPU, they've got to be, pixel. They have to match up color correction wise and things like that. So, we're doing a lot of work with software companies to make sure that that process gets done seamlessly, because, from an end user perspective, us developers really have to look at making sure that to the end user it doesn't really matter, right? They press the click button and they want to render a video project. To them, they just want it done fast. It doesn't matter if it happens on the CPU or GPU. And so it's kind of our job as a developer community to make sure that that gets done seamlessly and as fast as possible. And now there's a lot of new exciting opportunities to offload that to the GPU. And that's a lot of what we're working on now.
So how would you decide what goes on the GPU or on the CPU, for instance? Are there something that lends itself well to going on one versus the other?
GPUs are really strong parallel processing compute units. So any algorithm, whether it's video processing or image processing, for example, types of algorithms that can be broken up into small chunks and then run in parallel on all the hundreds of compute devices, compute cores that exist on a GPU. Those are the kinds of algorithms or compute tasks that we'd like to move on to the GPU. The GPU is basically composed of hundreds of small compute units that run in parallel. So if we can take a big problem and split it into small problems that can run in parallel, we can get excellent performance on the GPU, much better than you could on a CPU. On the other hand, GPU isn't very good at general purpose computing with a lot of branches and conditionals. So in that case, we want to do that kind of processing that's typically very serial to a CPU. CPUs are much stronger processing cores for that kind of operations. So in that case, that workload would be moved on to the CPU.
Makes sense. You spoke a little bit about OpenCL. Have you had a chance to actually use OpenCL yourselves yet?
Just a little bit on my own, and all I can really say at this point is it's going to be a very exciting API for software developers, because what it really brings to the table is an industry standard for offloading to the graphics processor. And performance is looking very good from a perspective of developers want to take advantage of graphics processors, but today it's not exactly an easy programming model. Right? It's either low-level programming languages or proprietary programming languages. There's other vendors that have APIs that are, they're kind of neat, but they're very proprietary. So it's not exactly in the software developer's best interest to use the proprietary APIs. So OpenCL is really exciting, the fact that it's going to support multiple operating systems, multiple types of hardware, CPUs and GPUs, and maybe there are future computing units. Maybe there's future processors that we've got. OpenCL will be able to kind of take advantage of that from one kind of programming API. And there's a lot of interesting things that can be done, I think, with OpenCL, and making software developers' life easier by also being able to take advantage of the insane amount of power that's on a GPU, right? If you look at like CPUs, they've got maybe in the gigaflops of performance, but a high-end graphics processor from AMD ATI has about a teraflop of performance. That's a lot of performance that you can take advantage of. OpenCL is going to be it's really the API that the industry is heading towards as a standard API. So I think that's definitely where the future is going.
Yeah, and as a platform company, we're really excited about OpenCL as an API, because it does allow developers to optimally target platforms that have heterogeneous processing units, whether it's a CPU and a GPU or DSP or cell processor. You can, with a single API, target all of these cores efficiently and get the maximum out of your computer in terms of performance and flexibility.
I was just wondering how easy you think it's going to be for people to adopt this new up-and-coming API.
I think it's going to be a lot easier than it has been in the past to take advantage of graphics processors. Like I said before, a lot of the programming interfaces to graphics processors have been very low level, very difficult, almost assembly level languages. And so, it's definitely not as developer friendly. But now I think with OpenCL being easily integrated into a standard C, C++ programming environment, OpenCL brings graphics processing and graphics offloading processing to any user, standard developer, and that makes it easier, makes development time a lot shorter, and you can take advantage of all the computing resources in the system.
So what are you doing tonight here at the users group?
So tonight we're going to be joining the Adobe Photoshop users group here in San Francisco. We're going to be speaking and talking about our graphics processors, and joining in with the Photoshop users and learning about how they use Photoshop on AMD hardware, and interacting with our fellow Photoshop users.
And Justin and I are part of the larger DevRel team. So obviously we work with Adobe, which is one of the more important ISVs. But we're obviously interested in hearing back from other smaller ISVs. If they have interesting projects they'd like to work on with us, definitely take advantage of our website. Come in contact with us. We'd like to hear from you and work with you on your future amazing projects.
Right, just navigate yourself to developer.amd.com and send us an email, or check out all the stuff that we've got online. We've got a lot of great resources, optimization guides, coding tips, you name it.
Great. Thanks, guys.
Thank you.